So the last session we were discussing the formula for the standing wave in a string. As you can see, like example, we have an oscillator and a mass is attached. What is the purpose of the mass? The mass will experience the force of the gravity, that weight will be there, and that weight is actually equal to the force which this string will experience. So example, if the force or the weight here is 80 Newton, the string will also experience 80 Newton tension. So this T is the force or the tension in the string. What about mu? Mu is mass per unit length, like how much mass is there in a unit length. So mass divided by length will get the mu, or which is also known as mass per unit length. So if we want to calculate the speed of the wave in a string, so how to calculate? V is equals to under root T divided by mu. There will be experiment, all the experiments related to unit 1 and 2 we'll discuss at the last. So there is an experiment also to find the wave speed or speed of the wave in a string. So if we relate the two formulas, like speed of the wave in a string is given by a formula V is equals to under root T divided by mu, and there is also another formula that V is equals to 2L Fn divided by n. That's the first formula to know the wave speed in a string, and this is the second. So when we compare these two formulas as we did in the last session, so that is 2L Fn divided by n is equals to under root T divided by mu. This n is divided, other side it will be multiplied. So as a result, what we'll get Fn is equals to n divided by 2L under root T divided by mu. So where it shows that the frequency of vibration, like as it oscillate, it produces a wave, and that wave will travel and it bounce back. So two waves which are traveling in opposite direction combine with each other. So as a result, when they combine with each other, this will give rise to a standing wave. So and as it will produce a standing wave, basically what it produces, it will produce a pattern of node and antinode. So we can work out the wavelength, we can measure the distance between the two successive nodes, because it is easy to recognize, and distance between two successive nodes is equals to lambda by 2. Or three successive nodes, we can measure distance, that is known as lambda. So using this, we can work out the wavelength, and after working out the wavelength, we can use the length here, tension, how much load is attached, that is the tension T, and mass per unit length, like mass of the string divided by the length of the string, we will get the value for the mu. So when we substitute, we'll get the frequency of this oscillating system, and it shows that this frequency is directly proportional to tension. If you apply greater tension, like if you increase the tension in the string, the frequency of the vibration will also increase. It is inversely proportional to length. If you use shorter length of a string, it will have a higher frequency as compared to longer length. And it is inversely proportional to mass per unit length. Under root of the mass per unit length, it means like if you use a thinner wires, they will have greater vibration or higher frequency as compared to a thicker wire. So these are the parameters which will affect the frequency, that frequency proportional to mass per unit length, tension, directly proportional to tension, and inversely proportional to length and mass per unit length. And this application of this wave in a string, the best and the simple example is a guitar. Because in a guitar, you will find that knobs are there. These knobs at the end of a string, like if this is a guitar, so there are wires or string. So what a guitarist is doing, there are knobs there at the end, adjustable knobs are there. So a guitarist can change the force here on the knob. So when a guitarist change the force on the knob, basically he changed the tension, and when he changed the tension, the same string can produce a different frequency. If we increase the tension, the frequency of the vibration will increase, and if we decrease the frequency tension, then the frequency for vibration will decrease. How a guitarist is adjusting the length of the wire or a string which is vibrating. So by using the fingertips, like a guitarist place a finger at certain position of the string. So by using these fingertips, they're changing the length of the portion of a wire which is vibrating, and as a result, what happened? It will produce a different sound of different frequency. If they use a shorter, like if they want to produce a high pitch or a higher frequency, then they reduces the length of the string which is while vibrating, and if they want to produce a lower frequency, then they increase the length of a string which is vibrating. And what mu refers to? Mu refers to the thickness that is fixed during a playing a guitar. It cannot be changed, but it is already built in, like different strings which are used in the guitar. They have different mass per unit length. That's why they are producing a different frequencies. Then the pattern of the wave which is produced in an open air column. The pattern of the air wave which is produced in an open air column, as we discussed in the last session, then always the open end, it will produce antinode. So this will be antinode, this will be antinode, and between the two antinodes there will be a node. So this pattern, when it will produce antinodes at both ends, the minimum vibration distance between the two successive antinodes, it is lambda half of wavelength or lambda by 2. So we can say that lambda by 2 is equals to L, or we can say lambda is equals to 2L. So as you can see, lambda is 2L. And what about this P? How we frequency? So we have the formula V is equals to F lambda. When it is vibrating in one loop, we can say F1 and lambda 1, or here they normally use the fundamental frequency, so they use F naught. So lambda 1, as we know, lambda is equals to 2L. So in place of this lambda, I can write 2L. So V is equals to F naught into 2L, or V divided by 2L is equals to F naught. So V divided by 2L is equals to F naught. And if it is vibrating, like this is a second way it can vibrate. So here is antinode, node, node, and antinode. So distance between the three successive antinodes, that is equals to lambda. So this whole distance will be equal to the lambda. So we can say this is lambda, or length of the pipe is equals to lambda. And then we can work out the formula, that using a formula V is equals to F lambda, frequency when it is vibrating after the fundamental, the first overtone, we call F1 here. And lambda, what is the lambda? Lambda is equals to L. So we can say V divided by L is equals to F1, or F1 is equals to 2 F naught. So means if it was vibrating here in 30 hertz, then in first overtone the vibration will be 60 hertz. Then the second overtone means the third harmonic. Fundamental means first harmonic. These are the terms which you should understand, because in exam they sometimes use the term harmonic, sometimes they say first overtone. So what is the meaning of first overtone? Means first wave which is produced after the fundamental, which is also known as second harmonics. So first overtone is actually second harmonic, and second overtone is actually the third harmonics. So it is same as when it is for open column of open air column, a pipe which is open from both ends, it is same formula as wave in a string. As we discussed that derivation, the wave in a string, you can see the frequency and the wavelength formula is same. So open pipe and wave in a string, they have the same formula. But in closed pipe, it is a bit different. How it is different, as you can see, in a closed pipe, always the closed pipe means a pipe which is closed from one end, and alternate is it will produce node as the other ends, means the closed end, and no antinode at the open. So when it is vibrating as a fundamental, the distance between node and antinode is quarter of the wavelength, because three successive nodes, that is lambda. Two successive nodes, that is lambda by 2. But node and antinode, like between two nodes there is antinode, so that will be quarter of the wavelength. That's why we can say the length is quarter of the wavelength, or we can say the wavelength is equals to 4L. So wavelength or lambda is 4L. And then the frequency, we have the formula V is equals to F lambda. So V is equals to F lambda. The lambda is 4L, so we can say V is equals to F into 4L, or V divided by 4L is equals to F. So that is the formula to calculate the fundamental frequency, the speed of the wave, standing wave divided by the 4 times the length. This will give us the frequency of this vibration. But if it is vibrating in the first overtone, means the second harmonic, so this is node, and antinode. So distance between two successive nodes, it is half of wavelength, and node on antinode, it is quarter of the wavelength. So this distance will be lambda by 2 plus quarter of the wavelength, lambda by 4. So 4 is LCM, 2 lambda by lambda. So when we sum this, it will be 3 lambda by 4. So the length here is equals to, we are talking about the second one, the first overtone. So L is equals to 3 lambda by 4. So if L is 3 lambda by 4, lambda is 4L by 3. And we have the formula V is equals to F lambda. When it is vibrating in first overtone, we can say F1. So V is equals to F1, and lambda is 4L by 3, or 3 is multiplied, 4L will be divided into V. And when we simplify V over 4L, what is V over 4L? That is F0. So 3F0 is equals to F1. What does it mean? It means that, like, if originally it was vibrating in 50 hertz, for first overtone, the vibration of the frequency of a vibration will be 3 times. So it will be 150 hertz. If it is vibrating in 2 loops, like the second overtone basically, or third harmonic, so then the frequency will be 5 times. So it increases with a multiple of, like, odd number here. If for the first harmonic, it is F0, but for second harmonic, it is 3F0. For the third harmonic, it is 5F0. For the fourth harmonic, it is 7F0. For the fifth harmonic, it is 9F0. So the frequency does not, in the previous example for open pipe or a string, when we reduces the wavelength, the frequency double or frequency increases. For first harmonic, it was F0, but for second harmonic, it is twice. The third harmonic, it is 3 times. The fourth harmonic, it is 4 times. But in case of a closed pipe, the pipe which is closed from one end, it increases by an odd number. Like here, it increased by, it is F0, increases by 3, like become 3F0, 5F0, 7F0, and 9F0, and it so on. As the number of the vibration increases or the loops increases, the frequency will also increase. So if I say, what is the frequency of the third loop? Third loop means third harmonic for a closed pipe. So what is the frequency for the third harmonic? So this is the first harmonic. This is second harmonic. First harmonic is also known as fundamental. This is a third harmonic. So third harmonic, it will be like the frequency for the third harmonic will be 5 times the first harmonic. But if it was a open pipe, for open pipe, like if we say third harmonic, it will be 3 times F1. So you have to learn these formulas for a wave which is produced in a string as well as open and closed pipe. String and open pipes are same. The only difference is the closed pipe. Is it clear? The concept of a standing wave? So whenever two waves travel in opposite direction, they give rise to standing waves. Now we'll do some examples related to standing waves, so you will have a better understanding of this. So this assignment is related to standing waves. In the first part, the two waves which are having a wavelength of lambda from a single source, they diverge and then meet again. Which of the following situations cause a constructive interference? Constructive interference, the constructive interference means when they increase the effect of each other. So in terms of, for a constructive interference, the phase difference should be 0 or 2 pi, and the part difference should be lambda or 2 lambda or 3 lambda or so on. So as I mentioned, like there are two waves which are produced from a source, and they diverge like to one point. So when they combine, like wave is traveling, and the other wave is also traveling. So when they combine with each other, if what is the meaning of part difference? Part difference means the difference in terms of wavelength. And what is the meaning of phase difference? It means the difference in terms of angle. So when the two waves combine here, they should either cover the same distance or one wavelength extra, or one wave travel one wavelength extra, or one of the wave travel two wavelength extra or three wavelength. Because when they travel one wavelength extra, then they will have the same phase when they combine at that point. So as a result, when they combine at that point, this will give rise to a constructive interference. So the part difference will be equal to lambda. As you can see here, the structure question, an experiment is carried out to investigate the speed of a transverse wave on a stretched length, as you can see in the figure. The vibration generator causes a string to oscillate. So this vibrator is causing a string to oscillate, and as a result it produces a wave. The wave travel, strike this fixed end and bounce back, and two waves, when they combine with each other, they give rise to a standing wave. So determine the wavelength of a wave when vibration is shown. As you can see the vibration. So how to determine the wavelength, how we can work out the wavelength? First we have to check the number of the loops. Like example, this is node, this is node, this one is node, node and node. We know distance between the three successive nodes is lambda, and then again three successive nodes, it's also lambda. So means the total length is how much? The total length is 2 lambda, because lambda plus lambda, so total length is equals to 2 lambda, or length of this string is twice of the lambda. But in the question we need the wavelength, so how we can work out the wavelength? So wavelength will be equal to half of the length, so the total length is 1.7 divided by 2, which is equals to 0.85 meters. Is it clear, this first part? Then the second part, we need calculate the speed of a wave in a string. So the mass which is attached is 0.2 and the mass per unit length is given. The formula to get the speed, V is equals to under root T divided by mu. So mu, mass per unit length, is given. But what about T? T is the tension in the string, and that is equals to the mass weight which is attached. So the mass of this object is equals to 0.2, but we don't need mass, we need a weight. Because the weight is the force, the mass is not the force. So to get the mass, it will be 0.2 times the gravity, which is 9.81. So we multiply, we'll get the weight. And that weight is actually equal to the tension in the string. So we'll substitute the value for tension in the string. So V is equals to under root T divided by mu. And T is actually equal to the weight of an object, which is mass times the gravity. Mass is 0.2 and the gravity is 9.8, so which is 1.96 Newton. So 1.96 divided by mass per unit length, which is 4.5 into 10 to the power minus 3, and take a root. So when we work out, it will come out 20.9 meter per second. The next part, figure the frequency of a vibration generator is reduced. So we reduce the frequencies of the wave until the wave pattern is shown. Explain what effect this would have on the speed of the wave of the string. So as you can see, as we reduces the frequency, so frequency as or the wavelength is increased as the frequency is decreased. So we have the formula. You can relate two things, because speed of the wave V is equals to under root T divided by mu. So in this question, we did not change the tension. Tension is constant, same, and mu is also same, does not change. So if these two factors will not change, the V will remain same as it is. But what happened as we increase, like reduces the frequency, if the frequency is reduced, the wavelength will increase. We can also use the formula V is equals to F lambda. So frequency is decreasing, but the wavelength is increasing, but their product will be same. That's why the speed will be same. So speed of the wave in a string changes either by changing the mass per unit length or using a different string, or changing the tension in the string. Some of the topics are actually interference that we will discuss, but now we are specifically discussing standing wave. So a student investigated how the frequency of a vibration of a string vary with the tension. The student connected the mass. As you can see, the mass is attached, the length is marked. A signal generator was connected to vibrator. The signal generator was adjusted until the standing wave or stationary wave is produced. Explain how nodes and antinodes are created, and it's of 3 marks. Sometimes the same question they ask how standing wave is produced. So how to write an answer whenever a question is there related to the production of this standing wave. So first thing you will mention, 1 mark is for mentioning 2 waves travel in opposite direction or waves meet each other after reflection. As you can see, when we disturb the when the frequency generator vibrate either up or down or right or left, so that produces that vibration actually travel and bounce back. So two vibrations, two waves travel in opposite direction give rise to standing wave. So the first point you can mention here, that two waves traveling in opposite direction meet each other form node and antinodes. And the region where they have the maximum amplitude is antinode and the minimum is the node. So this is always, this should be the answer always, that in which you refer how the standing wave is produced. The next one, the student changes the weight applied on the string and adjusted the frequency until same stationary wave is set up. The student plotted a graph for f square against w. Explain why the f graph will be a straight line. Look, we have the formula. This is a derivation plus the comparison. We have the formula v is equals to under root t divided by mu. And we have this is the speed of the wave in a string. And we already have one of the formula that v is also equal to f divided by 2L. When it is vibrating in one loop, it is f divided by 2L. So when we compare the two equations, we can say f divided by 2L is equals to under root t this one is v divided by 2L because the frequency here. So v divided by 2L is equals to f, or we can say v is equals to 2LF. So we can compare the two equations. So when we compare these two equations, like we have 2LF is equals to under root t divided by mu. But we want to sketch a graph for f square and t. So we should square the equation both sides because otherwise we don't get a square. So if we square both sides, it will be 2LF whole square and it will be under root t divided by mu whole square. So root and square cancel. This will be 2 L square f square is equals to t divided by mu. And f square, if we find for f square, is equals to 1 divide, and this is not 2, this will be 4 because square is there of 2. So it will be 4 L square mu into t. So you can see when we compare with the equation of straight line y is equals to mx plus c. So on y-axis, if we have f square, like on y-axis, if we have frequency square, on x-axis, if we have t, what will be our gradient? The gradient will be equal to 1 divided by 4 is constant, length is constant, and mu is constant. So it means the gradient will be constant. And whenever you have a constant gradient, it means it will be a straight line. Is it clear, this question? That how the graph will be a straight line for f square versus the L, f square versus the t. And so 5 marks, and the reason why, because this include derivation. Describe a method that can be used to confirm that the frequency value stated on the signal generator is correct. So how we can work out that the frequency value which is mentioned on the signal generator is correct? So using a camera, we can find the time period. So by using a camera, we can record the motion and find the time period first, like time to complete one vibration. And after knowing the time period, we can work out the formula f is equals to 1 over t. So like the frequency at which the waves are produced is same as the frequency of the oscillator. And then tension is given, the frequency, calculate the mass per unit length, and length is also shown. So we have the formula that v is equals to f lambda is there, or we can say f lambda is equals to under root t divided by mu. And length, when it is vibrating in one loop, so lambda is equals to, because L is equals to lambda by 2 when it is vibrating in one loop, so we can say lambda is equals to 2L. So in place of lambda, we can substitute 2L. So f into 2L is equals to under root t divided by mu. Or we can also use the previous formula which we already derived, that f square is equals to t divided by mu 4L square. So we have frequency, we have tension, we have length, so we can find the mass per unit length. So we just have to substitute the value. Frequency is there, tension is there, length is there. Just substitute to get the mass per unit length. So these are some questions related to standing wave. In the next session, we'll do more questions related to the topic. Any question or a doubt related to the class today? So I'll end the session and share this with you.